Welcome back to the discussion of spatial computing. In this video, I want to give a glimpse of a current research project in my own group. And as you know, my group is now called the Spatial Computing Research Group. And we have done quite a bit of work over the last several years, including some authoring of books and other material. So, the spatial database book we used in spatial querying, you saw a chapter from there. We also saw several articles from Encyclopedia of GIS as supplementary reading over modules 2, 3, and 4. The group has been involved in managing a journal, which publishes computer science research for GIS, that's Geoinformatica, managing some of the meetings, symposium on spatial and temporal databases, as well as geographic information science. And most recently, we helped organize a community visioning workshop for Computing Community Consortium. And this was something that's part of your reading in this week. And you can kind of see the community research vision where this field is headed, and there are a lot of exciting ideas in this report. Now, my own personal work has focused on two sub-areas of spatial computing. Back in 90s when I started my career, it was mostly focused on spatial databases, something reminiscent of spatial querying world that you saw. But we went well beyond querying to look at also algorithms, query processing techniques, indexing, and so on. So here are a couple of projects from that era, and many of them in some sense are still very interesting even though platforms have changed. Okay? So one project we did, which was with Army, had to do with parallelizing geographic information systems, and they wanted to speed up retrieval of real geographic data to make tank simulators, flight simulators more realistic. So instead of video game like synthetic terrains, they wanted to use real terrains from the theater. So a problem in this case essentially is to divide a map. For example, here you are showing a set of polygons, and the idea is to divide up the work among multiple processors in a multiprocessing system or a cloud computing environment so that the workload for a range query is equally divided across processor. So in this map, actually the colors of the polygon, they represent processor assignment, so that if you see this little box, that's a range query, and hopefully the colors are balanced within that. And if that happens, then you have actually gotten a good speed up on cloud computing or parallel computing platform. So back in mid-90s, we were working with connection machines on these problems. Another major theme in the group has been on routing problems. And all of us did talk about location-based services. We all enjoy this shortest path queries on our cell phone or Google Maps nowadays. But it is, you may find it hard to believe, but these things were research projects back in early 90s. So at the beginning of my career, we got research projects to think about how roadmaps should be stored on disks and how routing algorithms should be done when computing power was much less. Okay? And it's really a pleasure in your own career to see your research come to fruition and come to commercial products. Okay? And we still have a new project in this area called eco-routing that I will go in more detail. Okay? But after 9/11, we also got involved with another very interesting routing project that had to do with evacuation route planning. Okay? As you may have remembered from the interview of Betsy George from Oracle, let's say if lots of people have to leave New York City or Boston because of a hurricane, or this really happened in Houston, Galveston area with Hurricane Rita in 2005. If they all went to Google Maps and followed the routes from Google Maps, things will not look pretty. You will have massive traffic jams and poor utilization of road networks. So in evacuation route planning, the goal is to actually find a set of routes, and even those routes have to be used again and again in a pipeline manner by different groups of people. Okay? The problem gets much harder. It's a flow networks problem rather than a graph problem. Traditional solutions from operations research based on linear programming and time-expanded graph didn't scale up to large metropolitan area, and our group contributed some very scalable algorithm in this space about 10 years ago. Many of them actually got used in the field. Minnesota Department of Transportation chose our algorithms over the competition, and Fox TV did a nice review of that. There was a congressional presentation and so on. Very, very exciting. We are still doing some work on commercializing this. But let's talk about a new research project, something that looks even further ahead. So we just recently received a grant from National Science Foundation to explore this new exciting field called big data. So we are looking at obviously spatial big data, and we are trying to imagine the next generation routing and navigation systems. So you probably already have heard about the big data. So I'll just quickly give you the opportunity here. So first opportunity is that when you use your Google Maps today or your cell phone and so on for routing, they usually give you a route that minimizes distance or travel time. Okay? But with all this concern about climate change and environment, won't it be wonderful that we could minimize greenhouse gas emissions or fuel uses? Okay? So try to imagine your next generation of routing system which allows you to choose the minimization criteria which may be more ecologically friendly. Okay? Well, why can't we do that using today's technology, Google and all? Okay? So we'll talk about that briefly. And also I wanted to tell you it's not pipe dream. Actually, some people have tried this. Some of you may have read this story about UPS, a large delivery system, changing their routes, and they like to avoid left turns. So let me pause here for a second or two and ask yourself what's going on in left turn in United States. If you are in Britain or India, it will be right turn. But in United States, something goes on in left turn that UPS doesn't like, which is waiting. Okay, left turn means you have to wait for the opposite traffic to clear, and you're idling your engine and you're losing fuel, right? And in case of UPS, when they changed these routes, their savings were very, very significant, millions of gallons per year. And nowadays, in fact, the newer cars, they turn off the engines when you're waiting on left turns. So now you can imagine if UPS can save millions of gallons, what happens if all of us start trying to do that, right? A society as a whole will gain a lot of, it will reduce fuel consumption and greenhouse gas emission. Okay? So this is an opportunity, and the question is, what can we do towards that? So there are new data sets which are coming online. One we call temporally detailed roadmaps and GPS traces, which can actually give you a very good hint on where the idling is, where the delays are. And once you leverage this data, you can reduce that waste of fuel. Okay? But why should computer scientists play in this space? Isn't this a mechanical engineering or operations research problem? Well, there is computer science challenge. And one thing, if you remember in module 3, we learned about shortest path algorithms like Dijkstra's and A-star, and they all assume dynamic programming principle or subpath optimality. It turns out that if you change your cost metric from distance or time towards fuel or greenhouse gas emission, then the dynamic programming property does not hold. In other words, our algorithms are not going to help us in this problem. We need to start afresh and design new algorithms. Okay? So this is one opportunity in this space, and there are other opportunities. For example, today we usually say, well, if I start right now, what's the shortest path? But if you had these new big data sets like temporally detailed roadmaps, which knows your typical week's behavior minute by minute for the typical week, you could ask a different question. You could say, well, I have a meeting at 9 a.m. What time should I leave home to spend least amount of time on the road network? Okay? And it is something that today's roadmaps cannot do, but the new roadmaps which are temporally detailed can do. And there was again a small experiment in Beijing where they showed that if you leverage GPS tracks, you could beat Google Map based routes by 30 to 40%, okay, by adjusting your start time and taking advantage of time variation. Okay, so again, very, very exciting area, and there are many opportunities in leveraging big data. We'd like to acknowledge the support from National Science Foundation. This grant, which is in red arrow, is supporting some of this research, and there are other grants listed, which is supporting other work in our group. So hopefully this gives you a glimpse of one current project that's going on in our group. Shortly, we'll look forward to seeing you in another video. We'll give you a glimpse of another project in the area of spatial data mining. Thank you for your attention.